welcome to Scaling Your Kubernetes Clusters Without Going Broke. I have an introduction already. I'm the Site Reliability Engineer for Subsplash. Most people probably don't know who we are. We mostly do software for nonprofits, websites, mobile apps, and a lot of video streaming, which is kind of what led me to this conversation. Before I continue, I just have a quick question. Is there any Lakers fans here? No? Okay. I'm going to represent then. I figured there wasn't, because if you were a true Lakers fan, you'd be watching them play the Celtics right now. So what led us and me here is my team and I, probably like a lot of you, have noticed our cloud infrastructure spending kind of going up and up. And we looked at various ways to take care of that. Like I said earlier, we do a lot of video transcoding, and I don't know if any of you have looked at the prices for GPU nodes on AWS. It's pretty expensive. And so we worked through this to kind of try to see what we could do to optimize that. I'm going to kind of just go over just an overview of what the standard setup is if you're using HPA, VPA, cluster autoscaler, a little bit of understanding of the unique issues with using those, what the solution for me, like I said, if you guys read the description, it's going to list Karpenter. So how to use Karpenter, the best practices with it, and optimizations for it, and we'll go through there. And now that I'm looking at this does not look like the right deck, but we'll make it work. So typically, with your setup, you're going to have a horizontal pod autoscaler. It works really well with cluster autoscaler, but I don't know if you guys have ever really dug into how the topology of your pods is working, but like you want to be spread across as many zones as possible. It works either with cluster autoscaler or without. However, to do it properly, it's a lot more work with cluster autoscaler. If you don't do that, you do cluster autoscaler, you're going to get, you might need to be in zone A, but it's going to try to automatically put your nodes in a balanced across the zones. So the new node may be in zone C. There is ways to do cluster autoscaler without that, but it is a lot of work. Second case, which is my least favorite case, is vertical pod autoscaler. I guess I should probably point these out. Can you guys, do these flows make sense? HPA, it's reading the metrics, it sees you need a new node. Replica set increases it, you get a new pod on an existing node. Vertical pod autoscaler, same situation, but it may determine that you need a smaller or a larger pod. Maybe your pod had an kill, what have it. But the concern with VPA, right, is, okay, well now your pod needs more memory. Is that pod going to fit on a node you already have, right? It's very constrained to what you have, because with cluster autoscaler, you have to be pretty explicit. Also with VPA, it may not actually even end up on the same node again, because it's going to basically force your pod to it's going to kill your pod, and your pod's going to come up somewhere else. There are features for Kubernetes to work around that for the in-pod update for resource requests. However, if you're using AWS, they don't have that feature gate turned on yet, but it will be coming soon. But even if that was the case, vertical pod autoscaler has not been updated for that. Now, with those combined, when you're using cluster autoscaler, like I said, it's very constrained. Normally, you're going to have either, if you're doing it properly, you're going to have multiple policies, one for each zone. So you basically have an autoscaling group for each zone. It doesn't work well if you don't do that, because as I said, by default, you're going to have 9 nodes. It's going to put 3 nodes in each AZ. But maybe because of your topology, you actually need an extra zone somewhere else. The other issues with it is the instance types are very inflexible. You basically are going to have an ASG that's going to have nodes that basically have the same CPU and memory. And if you need any deviation from that, maybe you need another autoscaling group for nodes that have GPU. It's going to be another autoscaling group, and it's going to just keep going up from there. If you want to add spot capacity, that's another dimension for autoscaling groups you're going to be setting up in cluster autoscaler. Typically, with this setup also, you're going to have very low cluster utilization. A lot of nodes are going to be half empty, and it's just not going to be able to balance it right, because even though you have a new node, depending on your affinity, the scheduler may not actually have used it for that particular case. And because it is using ASG, it is notoriously very slow to scale. That part about VPA may break a working deployment, that was kind of what I talked about earlier, is that it's going to update your resources, but there actually may not be a node that you have that even can support that. And last, it's kind of very slow for innovation. Depending on how you're trying to set up your groups and your nodes, you may have various reasons to try to separate them. Maybe you're trying to isolate different teams, right, so that they have their own auto-scaling group. Or you're just trying to isolate expensive resources. That's another another dimension for how you're going to have to set up your auto-scaling group. You end up getting tons of them. And a new team comes on, or they need a new type of node. Somebody has to go in and update this now massive list. And this slide here kind of demonstrates that, right? If I want, I have some R nodes for AWS, right? I have a ASG for memory, for Spot, for on-demand. I have one for, if I'm doing compute, one for GPU. Maybe you have some high network workloads that need a very specific node. And maybe you have some that need either like an NVMe or just have a higher EBS throughput. That's another one. And you're going to replicate that across the AZs. And this is a lot, even without considering the fact that if you're going to try to keep teams isolated to their own ASGs for whatever reasons. Usually it's because you don't want one team using up all of your capacity if they have a bug or whatnot. So I know this is very high level for Karpenter. I'm not sure how many people are familiar with it, but I will get deeper in how to do this. With Karpenter, right, it's going to work very similar to how Cluster Autoscaler works. However, if you're watching it, I'd probably wait for it to restart in a second. You're going to have some new nodes show up. Scheduler is going to recognize it can schedule them. It's going to put them into a pending state. The other ones are going to go into unschedulable. It's going to put the ones that it can schedule on that node. And then Karpenter, rather than using the ASG, it's going to work directly with the EC2 Fleet API to provision the cheapest node that it can pack those on. And when Karpenter does that, it's going to then compare not only that, but then 59 other instance types that are larger to see what it can get for the best price to fit on there. However, if it is Spot, and you have this configured for Spot, it is going to basically do the same thing, but also look at other dimensions, such as like how frequently are these nodes disrupted, and it's going to try to find the best balance for price in that case, so you aren't getting a Spot node that's going to go away in a couple of minutes. Did I hit the wrong one? I was on the same slide. Oh, sorry, I went out of track here. So like I said, the solution that I found, I think Karpenter is the best case for this. It's not going to support everything I wish it does, but you're going to get at least the minimum of what you would get with Cluster Autoscaler with some additional benefits. It can significantly simplify your configuration. So before, when I was showing you guys the AZ slide, this one, this would only be a couple of node pools with Karpenter, and I'll go over what a node pool looks like. Basically, though, it's going to look at your pod definition and make sure that you're getting the right AZ. It's also going to look at the fact of like how much memory you need, whether you need CPU, network, and you're going to get the right node for the cheapest price. So it's going to, like I said, it's going to choose the cheapest one. It's also much better at Cluster Autoscaler for consolidating nodes. So in the Cluster Autoscaler case, right, when it goes to consolidate a node, it may pick the one that has the lowest utilization, but that may actually mess up your topology for other pods. It may break other things. It probably isn't going to be what you want. If you do the version where I said you have like an ASG for each AZ, it is better at that, but it's still not going to be perfect. And Karpenter is open source. It was donated to the CNCF in 2023. Primarily, it was made by AWS and donated. So AWS is the primary provider you're going to find most of the documentation for and examples. There is a provider for it to work with Azure, and currently the GCP one is still in progress. But I really expect this to take off, especially, I don't know how you guys, your bill is, but like ours is crazy, and I would expect probably like half your bill if you were to switch to Karpenter versus what you had before. And I'll kind of cover some of our case and what we got out of switching to this. Yeah, so kind of worked around. Sorry. So how many people here have used Karpenter or are kind of familiar with its CRDs? All right. That's a good number. Cool. So like I said, this is still just kind of high level, and I'll get some detail later. There is another CRD, but for what you guys will be using if you're trying to use Karpenter, these are the main two. EC2 node class is really going to be like how you define what AMI you want to use. There's basically, you're going to get 3 built-in ones: AL2, AL2023, and Bottle Rocket. I think AL2 should go away. AL2023 works great. However, if you guys are using something like Cilium, Cilium isn't compatible with that. You'd have to switch to Bottle Rocket. The other benefit of going to Bottle Rocket is it does come with the NVIDIA device plugin already there. So if you guys are trying to use GPU stuff, you don't have to run a separate workload to do that. I would still probably recommend it just because you guys can adjust how it does slicing for GPU. But I'll kind of go over that slightly. One thing about this is this line right here where it says AMI selector terms, and I'm showing latest. Please don't ever do that. This is a slide, an example. The aliases are there. You want to pick one that has like if you're using AL2 or AL2023, you want to use the ones that have like the date alias because it'll work for ARM versus AMD 64. If you're using Bottle Rocket, it is slightly different, and I'm drawing a blank on the way it is. I think it's just a version number, but you'd have to go look to see what's in that's AWS, of course. For a node pool, I'm going to go over deeper detail on what node pools do, but this is the basic setup. Oops, sorry about that. You're going to have, just give it a name. You'll have a weight, and weighting is used when you have multiple node pools, so it's going to give you one of them will take precedence over another one, and I'll go over a case where you're going to want to use that. And then, the requirements are basically, you could think of them kind of just basically like a Kubernetes selector. Karpenter's documentation is really great for this, where they list out all the different labels you can use. There are some Kubernetes native labels you can use, like architecture, but most of them are going to be like, it really breaks down like the instance types. So you can either say like, I want an instance category, and here I have compute, general, and memory listed. They have another label where you could do like, I want to have a C6 node, right? Or you can do the whole family. But they break it down into labels like this. So this pool, depending on how Karpenter is going to see the nodes it needs to create, or the pods it needs to create a node for, when it tries to bin pack them and figure out the cheapest node, it's going to be able to leverage a C, an M, or an R type, and it's going to want the generation at least like a C4 or greater than C4. So it would be C5 or higher. And then the last bit, like I said here, I'm just doing AMD 64. One thing, if you notice with this, this would do, C5 node, C6, C7, C8. It's going to do any of those. It'll do the network version or the regular one, depending on whatever is going to be cheapest and what you need. So I have a much more flexible configuration for my nodes here, because I can basically cover almost all the cases I showed before. If you noticed, I don't have the capacity type in here, which is going to be for spot or on demand. So this would also work for that case. When Karpenter is going to get a node, if you have spot and on demand together, you don't have to do anything special. It's automatic. It's going to try to find a spot, and it'll fall back to on demand. So pretty much one configuration can cover a lot of cases. You probably don't want to do that, though. You're probably going to want to pick one of these 3 strategies. This first one, like I said, does work. And that last slide where I said that pool was for AMD 64, if your workload supports ARM, I would recommend you try to take advantage of it. The AWS nodes with Graviton are probably like 15% cheaper, and they have a slightly better performance. But even if you end up not getting a Graviton node, the fact that you're looking at them, you're going to have a better chance of getting a lower priced spot instance. But there is some issues with doing that, right? Like you either have to support both, or you have to make sure that you're restricting what pods can do. So typically, I wouldn't use the first, the single pool. You're going to want to use either a multiple pool or a weighted pool. Multiple would be the case where like you're trying to isolate for either just like I have Prometheus on a node, right? I don't want workload scheduled Prometheus. I don't want any issues or instability with there to bring down my observability for the cluster. So those kinds of cases, you're going to isolate them. You may do team isolation. I would recommend, if you're doing Karpenter, pretty much there's always going to be a case where you have a pool that's at least shared amongst a couple of teams. And because of that, right, you don't want one workload using up all of your capacity. So I'd highly recommend that you guys do resource quotas for your namespaces so that one team just can't go crazy and use up everything. And then the last case is mostly when I use weighted pools, I would use it for if I'm trying to just split up my pools. If you're going to do reserved instance or savings plans, you want to make sure that you're using the nodes that you for those savings plans first before you go to any other nodes and you get spot. It's just you have to make sure that you're getting your hourly commitment for savings plans. Saving plans also are a little bit trickier in that regard, is because the more explicit you are with what type of node you want, the cheaper the discount's going to want to be. And so if it can't go into that pool, you want it to be able to go to a fallback pool. So you want to be very, explicit with your savings plan if you can. But like I said, it has to have a higher port than the next one. And I'm going to go over what that would look like in a minute. 100 different node types with AWS, and I think it's over 700 when you consider like the size of the node. And if you can think of like trying to do all of this where it covers that depth, and teams and everything else, it is going to get kind of crazy. And so that's one of the main reasons, just for simplicity of configuration, I would use Karpenter. So in this example, I'm just having savings plans for a particular C4 node. I wasn't explicit on the size. I want to weight that as my highest weight so that it comes out of that pool first. There are cases though where, sorry, there you go. Point out the pool size, the weight. So you want that one to be your highest weight. Your limits, you don't want to set this any higher than what your savings plan is for, because once you're past your savings plan, you probably want to try to leverage a cheaper node, which is, in this case, probably not going to be C4. I'd want a newer instance, and I would want to leverage Spot. So just make this is just for your savings plan. Anything else, you want it to go to a different pool. But just because this has the highest weight does not necessarily mean that your pod will go into this pool. Your pod may put you over the limit of the pool, or your pod may just not fit into a C4. You may have other restrictions on there where you need higher network or something, and it's not going to use this. So this isn't a guarantee. It's just this is the best estimate to try to use this first. The other restrictions I have in here, like I said, it was C4, which I don't hope no one's using C4, but example. And in this case, like I said, this is the other one. It's AMD 64. And this one, this important part is this pool, you want it to be on demand only. You don't want it to use this pool and create a spot node, because that's not going to count towards your 20 CPU commitment for the savings plan. The next part of that would be setting up a separate pool for on-demand or spot. This one is probably going to be the pool that you have that has the most capacity. In this example, I have it as 200. That's probably, everyone's different. Probably not going to work for you, so don't do that. But it just needs to have a lower weight. So the weight on this one is 50. This one, it is for AMD 64 and ARM 64. This part is a little bit trickier because this is the ideal configuration, is you want to be able to support both. But if all your workloads don't have an image that can run on ARM, you need to restrict it somehow. So either you need to make sure that you go through and update the affinity for all those pods, or use a tool such as like Karpenter or something, where if there isn't a, if you don't have architecture specified in your affinity, you're automatically adding it. AMD 64 is usually pretty safe, but not so much for ARM. But ideally, you want everything to be able to run on both. That's going to give you the best chance for savings. In this case, I'm explicitly saying that I don't want it in, I don't want a T node because I don't want any credit-based nodes. I don't think that's a good fit for Kubernetes, and I just wouldn't want to use it. And all these requirements are basically, all of them have to be true for you to be able to, for it to get a node. So it has to, in cases, you know, it's going to be an or AMD 64 or ARM 64, and it has to not be a T node. I don't want one of these smaller nodes, like a nano, a micro, a small, or a medium. This is going to be very dependent upon what you have. But when Karpenter is going to calculate the overhead for a node, it's going to look at all the daemon sets, just the kubelet overhead, and see what's left, can what I need to schedule is going to fit on there. If you end up going too small on these, you're going to get a node, and it's going to fit like one pod. So most of your overhead is going to be daemon sets, so it's kind of a waste. Very, very specific to your setup, but you want to make sure that you are restricting some types. I personally, my setup doesn't match this one exactly. I'm also restricting just some types in general, nodes that just don't work well for me and would not make any sense. And like, I kind of skipped it here, but right below this one, I'm skipping specifically C4, M4, and R4. The reason I did that with this setup is I wanted this to work for some GPU nodes. And so I'm not doing an instance type, so I don't have M, R, or C listed. So it's going to basically work for every class. It just has to be greater than generation 3. So I could get a G4 node out of this. But if it is a C, an M, or an R, I don't want to use C4, M4, R4. I'd rather use one of the newer generations. So it can be very flexible for how you set this up. And the last bit is, like I said, this is going to work for both architectures. And just you got to make sure that you either are handling that. Otherwise, you know, your pods are going to come up. They're going to go on a node they can't, and they're just not going to be able to start. They're just going to crash. There is some things I probably should cover with this, though. As I said, this one will work for a GPU instance. GPU is very expensive. I don't have to configure a separate pool, but those GPU, that CPU count, right, that limit is going to come out of that 200. And so if I don't have those restrictions on the resource quotas for the namespace, somebody could spin up a ton of GPU with this, right, and it would basically soak up the pool, and it's going to be a lot of money. Those cases, you may want to just create a separate pool and restrict how it's being used with a taint. That's up to you. It can work this way. Karpenter is not going to accidentally pick a GPU node. They're just too expensive. It's going to find a cheaper node or a spot node first, so it's not going to happen by accident. Someone's going to have to specifically ask for it. But you want to make sure you're putting protections in place so that if something does go awry, you know, it's not going to cost you a fortune. So the next case, a little bit more detail on this, would be disruption. I think disruption is really important. Karpenter handles disruption. It's pretty smart about it. It's not going to try to consolidate a node that it can't. So in this case, I would heavily recommend that there's two ways to tell Karpenter really that not to disrupt. You can either use the pod disruption budget, so it has to meet and keep the budget if it's going to consolidate a node. That's the ideal way. The second way would be to annotate your pod to do not disrupt. If you do that, Karpenter's not going to be able to get rid of that node as long as that pod is on there. So I would heavily recommend you only use it for short-lived things like jobs and things of that nature. So I really focus on that. When Karpenter does go to consolidate those, In this particular case, it's going to consolidate whether they're empty or underutilized. When it's only going to do that, though, if it sees that those pods can go on to another node. It's going to work two different ways for this. So that's the policy, but the budgets are what's important here. It's only going to get rid of 20% of the nodes, but it's only looking at ones that are empty. So if I'm during like a day where I know I scale a lot, in this case, if you have a partially utilized node, it's not going to get rid of it. That's specifically, is that work for you? But it may not be the case. You may want to just remove that restriction and just have it work for all cases. But it's just something to keep in mind. There is another way to configure this. You can have a separate rule in here where you just put a flat count for nodes. And the way that's going to work is it's going to try to do 20%, but if 20% exceeded that number, like say I had nodes 5 there, it's going to restrict it where 5 is going to be the max. It can't break those rules. This second rule is really around covering the cases that the first budget didn't account for. So I only want to let nodes get consolidated, underutilized. This one says do it for an hour after midnight. The drifted case is where Karpenter has there's an update to the AMI and it can swap the node out. So it's drifted from the EC2 node class. It'll consolidate that node and spin it up with the new AMI. Now this is just how it's going to force it, right? If you're scaling during the day normally and the EC2 node class is already updated, those new nodes are going to have the updated AMI. But this is just you specifying disruption to force the nodes that didn't come out normally. And then this last bit is my preference, but everything isn't coded perfectly. There are memory leaks, there are other issues. And this bit right here says that, after 30 days, we're going to cycle the node anyway, just to make sure that we're getting a fresh one. The termination grace period is extremely important if you use that setting, because Karpenter is going to try to consolidate that node, but if it has do not disrupt on it or something else, it's just going to hang around and it's going to have one pod on it forever. And so the termination grace period is basically how long that pod has to just finally come off there before Karpenter's going to go, all right, I'm done with you. We're going to get rid of this node anyway. So it's just going to kick it off. I would recommend that. This isn't required, but I would still recommend it because, like I said, there's always some issues. So, and I've definitely ran into memory leaks in the nodes before. I have a little bit more to go over. This bit, previously that was pretty much like how you want to configure Karpenter for saving you money. This is just a little bit of details on how Karpenter is going to pick the nodes. So this is the pod level specification. Karpenter is going to treat your required selectors and your preferred as actually being required. So if, in this case, right, I said I prefer it to be in spot, Karpenter actually treats this as both as required. Once the node's there, or if there isn't any node there, like the schedule is going to respect it as is. But if I had some other selector here, like say I had, instead of spot, say I was looking for ARM, Karpenter is going to treat it as a requirement because it's actually going to get a new node. So it's going to treat your preferred as like this is what you want. But once the scheduler gets it, it will respect this exactly. I can't tell you exactly why they chose to do that, but if you prefer something and I'm going to go do it, right, I might as well give you what you want rather than this setup, which is just, a best attempt. Wow, and that's just the same thing I just said. This one is strange, and I included this here just because this kind of bit us with how we were working with GPU. I don't know if you guys have used time slicing. Kubernetes has the concept of extended resource. So you have your CPU, you have your memory, GPU. With custom resources, you can basically say, like, this node has a network capacity of some value. Even though the scheduler, if their node has that and the scheduler can put the pod there, Karpenter isn't going to know how to schedule those nodes. So it's not going to work for Karpenter. You'd have to have the node already there. There are ways to work around that. Back to when I said that Karpenter has a well-defined set of labels. Even though I can't, see if I can give you an example. Say I have a node that had a gigabit network, and I have 2 pods that need 500 meg network. Normally, if I had the schedule on there, right, it's going to see this pod needs 500, that pod needs 500, so they know that they both can fit on the node. With Karpenter, you can't do the custom resources. I'm hoping they add it. Instead, what you have to do is just, in your affinity for the pod, say that you need a node with a greater than and a specific network value. You'll get on the higher bandwidth node, right? But it's not going to make sure that the resource is partitioned out correctly. And how that plays into here is with GPU nodes, frequently you'll see what they call time slicing. There'll be either the NVIDIA device plugin I talked about earlier, or you'll run your own setup where the node normally only has 1 GPU, but as far as workload's concerned, once the node comes up, that device plugin changes the capacity of it. Now the node has 2 GPUs. Karpenter can't know anything about that. So if I have 2 nodes that say they need GPU, or sorry, 2 pods that say they need GPU, Karpenter's going to end up creating 2 nodes. Each one has 1 GPU each. And if you don't do anything and just go with that as it is, even though the nodes, because I've time sliced them, each one can support 2 GPUs, the pods are going to get evenly distributed, so you're going to have 2 half-utilized nodes. The workaround for that is, and it's not perfect, right, is in your workload you would do a pod affinity selector so that you prefer to be scheduled on a node where one of your pods is already running. What that's going to do is Karpenter's still going to unfortunately start up 2 nodes. They're going to update to say that there's 2 GPUs on each one, but the scheduler is going to see this and it's going to put both pods on 1 node. And then what's going to happen is the other node is underutilized, so Karpenter can consolidate it. So there's still some waste, but it's better than only utilizing half of each node. Does that make sense? I hope. Like I said, it was my specific case, but I feel like with the way that AI is coming along and a lot more GPU, it's probably going to be relevant for some cases, or a lot of cases. And following these practices, I didn't get this gentleman's name. For our case, right, we had a much higher restriction on what kind of node we could run on. And as of December, I think we had 500 GPU nodes, and we had about 67% were able to go on Spot. However, you can't count on Spot because with the way AWS works, they can take it away at any time. You get a 2-minute warning with Spot, and Karpenter can work with EventBridge, and you can have those messages go into a queue. So that way, if you have that 2 minutes, it can try to consolidate, prepare to consolidate nodes. So the node will get cordoned, and those workloads can get moved. What was I going to say about that? Sorry. So that's how you can handle the Spot disruption. I would still prefer to go on Spot, but you're going to want to be prepared. Like I said, it'll fall back to an on-demand. If you do really have those really expensive workloads, what you're going to want to do is, if it's like a Kubernetes job or something, look into something like, there's a product called Q, and you can kind of throttle those jobs and preempt them, so that way your number of pods doesn't just massively spike. It's kind of more flat throughout the day, and so it can try to leverage Spot more. I did not do that, and like I said, I had 500 nodes, and it was 67% of them were on Spot. January rolled around, and I think I killed the Spot economy for everybody, and I dropped down to 6% Spot usage, and it was not a fun time. like I said, though, my case was specifically, it was for a very particular GPU. But if you're following the practices where you're just being as flexible as possible with what kind of nodes, like my first example where I said I can use C, M, and R, and didn't really put in too much beyond that, the more flexible you are, the more likely Karpenter's going to be able to find a spot node for you. And that's really the key to being able to get available spot. My case, I needed a G6 extra large, and my stuff could only work on a G6 extra large until there was work done on the workload to be able to support other node types. So I was really locked into that one, which is, like I said, that's why I killed the pool, is because I was only getting that one. Ended up being very expensive. So be as absolutely generic as possible. If your workloads can be on spot, you want to run them on spot. I would suggest trying to put spot in your main pool, but if you have to do a setup where you split it off as a separate pool, either either put it as a lower priority and have workloads specifically ask for it, because if it's lower priority, it's going to use the higher level pool first, or you're going to want to put a taint on it and have your workloads that can run on spot tolerate it. Spot is not going to be a very good fit for some workloads. There are some tricks if you want to kind of try more for a balance. If you want to run, say, like 80% of your pods go on demand and a smaller subset go on spot, there are tricks for that. I didn't put it in here. It's on the website, Karpenter's website, where you can basically kind of set it up and do it with selectors. I prefer to stay away from that simply because it's very, very specific use case, right? Because you have to do that setup for every different flavor you want. Like if this team wants to run 60% on demand and 40% spot, but the other team says, oh, we need 80, you're gonna have to duplicate that setup. So I prefer not to go that way. But whatever you have to do to get your stability and get your cost down, I mean, it's probably worth it in that case, depending on how big the workload is. So I wouldn't be completely against it, but I prefer to do as little as possible and spend my time and money getting, either another engineer or, SaaS product, so I don't have to maintain something else. I ran through this really fast, so I guess I just have Q&A, and I'll probably miss something. So if you have questions, please ask me now or afterwards.
I have a few questions. Maybe I'll
Yes.
When you were showing the instance type rule set that was fairly complicated, you had maybe 5 or 6 different rules to limit what set of instances would match against your Karpenter node pool.
Mm-hmm.
Is there some sort of like dry run, or like something you could say, like if I were to ask this for this node pool right now, which instance types would actually fall out?
So are you referring to this one?
Yeah, that one. So like, you said there's like 700, and it seems like Karpenter would know the 700, and you could basically go, of those 700, these 300 fall out, something like that,
So you're just wanting to see the types that it could select from?
Yeah, just to get a general idea that the rules that I'm setting are correct before like sticking it into an actual node pool.
I don't know of any dry run capability. They do have a listing on their website of basically all the types and the labels that they're going to use, so you can kind of use as a reference. If you wanted to, it's not a dry run, but what you could do is just add a taint to this and just do the smallest, pod possible with a toleration to test it. And if you really want to do it that way, you could probably remove the on-demand so that whatever node it's going to get, it's as cheap as it can be, and it's going to be, a spot, but it's not going to tell you,
That's more like a sampling,
Yeah.
though, instead of a overview. These are the set of instances that I will match.
Yeah, it doesn't support it that I am aware
Okay.
of. I'm sure there's a way you could probably calculate it. There's probably a tool out there for that, especially because I said they have all those labels listed.
Yeah.
Because you're going to find a label for pretty much everything.
Okay.
You know, it's architecture, CPU, who the manufacturer is. So these, like GPU, if you do want to leverage GPU and you need a specific type, I would recommend against like specifically asking for that instance type. And instead, Karpenter has a label where you can just tell it the architecture you need. So like if you need L40 or L40S or, you know, Ampere, there's labels for all of that. And so that'll give you, Karpenter can go, oh, well, here's all the instance types that support that. So, you know, it'll be easier for you. But yeah, there have to be a tool for it that I'm not aware of. Sorry, I don't have a better answer.
Yeah, I was just thinking because Karpenter has to be doing that math for you while it's running. If it could just do it up front and tell you, these are the selection. Okay.
I will say they add a bunch of instance types all the time. You know, before, you know, it was just the AMD and, you know, NVIDIA. Now there's the V1T. There's always new stuff. So even if that was the case today, it may not be the case tomorrow, which is, as far as your node pool setup, I would recommend you be as flexible as possible. And on the pod side, just make sure that you're only as explicit as you need to be to ensure you run, and keep it as flexible so you can save the most money.
Nice talk. I think you covered this briefly, but I think I missed it. So spot instances don't count towards your like savings plan or reserved instance spend. And I think you had like some, like Karpenter doesn't know what your reserved instance or like what your savings plan is, right? You
Correct.
just set up your node pools so that it like matches whatever you've purchased. Is that right?
Yes.
Okay.
Yeah, which is why in here I said, you know, I want to be explicit that you put this one as on demand, and this one you want to make sure it has a higher weight than the other ones, so that you're trying to make sure that you're at least meeting your capacity for, or sorry, not the capacity, you want to make sure you're at least meeting your commitment for the hours, and that limits 20 CPU. Like I said, just make it as at most as big as your pools. This may be a little complicated setup depending on your, you know, your account, because like you may have a dev account and a prod account, you know, and if you have multiple clusters in each, well, how do you really find the balance where you're not, you know, over, like you don't want to do your savings plan on each cluster because now you've done 5 times, you know, or whatever it happens to be on demand when you really only did it at once. So you're really going to have to try to like play with that and figure that out, so you're not doing any more than you absolutely have to.
I'm a big fan of all the things that you said. One thing that I'm unclear on is over provisioning for startup time.
Oh, I did not cover that. Generally, you probably don't need to do over provisioning, and over provisioning does work with Karpenter, but it's a better fit for cluster autoscaler. And the reason I say that is the way I've always done over provisioning is I'll have a deployment and I'll have like a, you know, a pause image that doesn't do anything.
Yes.
And I'll tell it, do you guys use Kita, or do you guys just, okay. No. Kita's great because you can tell it, you know, I only want to over provision, you know, this day during this time frame. I mostly only use it on my CI system because I know there's going to be a lot of jobs coming up.
That scales up and down a lot, yeah.
Yes, but the reason I only use it only with my CI system, right, is because whatever node it's going to provision, that's a very explicit case, and depending on whatever workloads you have come in, right, it may not be the fit that's best for those. My CI, you know, I'm using GitLab, so like I know it's going to be, you know, AMD 64 in this, you know, and I know the minimum size, so it works better. So if you're going to over provision, it's probably going to be for a very specific, like, spiky workload that you have to account for. In that case, you can do it because you know what kind of nodes those need. But other than that, it doesn't work as well with Karpenter.
That's what I was thinking too, because you can't, like, when you have a heterogeneous pool of nodes, then how do you say I want to have like an over-provisioned half of a node that's evictable? Because you have to give those in, like, you can't say 50%. You have to say 16 gig or 32 gig or whatever. So,
Yeah. If you're doing it in that case, right, you're probably doing it so that it's just, it's going to be on, like, the only pod probably on the node.
yeah.
And it's the normal cases, though, if you do it, like, you just want to make sure it has a lower priority and it's it can be preempted. But yeah, it's definitely harder with Karpenter, but you're saving it on not being so explicit. But Karpenter is so much faster because it's just dealing with the EC2 Fleet API instead of the auto-scaling group that I really haven't seen it be an issue. But in certain circumstances, probably more so if you have pods that are like some workloads that are just really slow at coming up, that extra little bit of time for a new node may just put you over the top. And so, yeah, those cases, it's going to be explicitly for that workload.
And another question I had was, I am much more familiar with cluster autoscaler, and what's the visibility of the things that Karpenter is doing or planning to do? Like with cluster autoscaler, it'll add those like node annotations. Hey, this is a deletion candidate. Is there the same thing with Karpenter or similar?
Yeah, Karpenter's still going to add the same or similar annotations, so you'll know. The one thing I didn't go over for CRDs was the node claims. So it's it's Karpenter's claim on a particular node. That node claim will match the annotations Karpenter's going to put on the node. And the logs are pretty good for you being able to find stuff. I dug in them through a lot when I tried to figure out why did I go from 67% spot to 6% spot. And I was like, why is this failing all of a sudden? And then, I looked and it's like, oh, the disruption was really high and there's just no nodes available. I used them all. It's really good for that, and the metrics out of it are really good. Karpenter is, depending on your setup, it's a little bit more memory heavy than I would like. I would say it's still probably less than cluster autoscaler, which keeps everything in memory. But the metrics on it are pretty good. And that's the only issue I've really had with Karpenter, was that when I first started up, I just started putting so much more on there, and I'm not running VPA, so I didn't go back and adjust the resources. So I did have it kill itself a couple times. That's the only issue I've had with it.
So Karpenter has problems managing its own scaling.
I mean, that really falls into the pod scaling, not the cluster scaling. But yeah, I would say I had a problem with it. I think Karpenter was perfectly fine.
I was just going to say the recommended configuration from Amazon is that you run Karpenter on a Fargate node so that it doesn't scale itself.
Oh, yes. Yeah, Karpenter definitely. There is a separate label for that where you want it to go in your managed node pool that you first set up your cluster. My setup, and probably the one most people will use, is you'll have like a minimum number of nodes, probably like 3. So you have the AZ spread. Karpenter, you want it on those. You don't want Karpenter on a node that it manages itself. That's a recipe for disaster. I mean, I'm here
Yeah.
regardless. So we can just stand here and stare at each other.
I'm
I'm sorry. I have a terrible sense of humor.
You're fine. The idea that Karpenter is going to pick the cheapest node type makes me think that it will. You had the slide where it was like, I have these pending pods and I have some unschedulable pods, and Karpenter will look at the unschedulable and figure out what's the instance type I need for those. Is the idea, what that feels like to me, like my knee-jerk reaction to that is that you'll always end up with like the smallest instance types, and then you might end up with, oh, I have a couple pods that are unschedulable, so I get a small instance, and then a couple more, then that's another small instance, but then the daemon sets start adding up. Is the idea that you eventually get to the point where they get consolidated into larger nodes, or?
It's really going to depend on how you set up the pool. Like I said, I restricted those several types. So it really depends on that. But Karpenter's all about, just in time launching of a node, so just the minimum of what you need. If you're scaling, like if it's, I'm trying to think of like, when does all the tickets and concerts and everything go on sale? Tuesdays? So like if you were doing something with that, you're probably going to be doing the over provisioning thing. But yeah, it's really going to just pick the smallest node. It, depending on the flux, it may not be a big deal. But in that case, you're going to want to, like I said, just make sure you're excluding those smaller types. If you're, I don't remember your name, sir. Sorry. We were talking about Argo earlier. I use Argo to deploy everything, and I love it. And one of the things I love about Argo is how easy it is for me to just, deploy to every different cluster without having to do a lot of work. You're going to be able to have more control over, now you could probably do it with anything with Helm, but more control over like what those values are. There isn't really any shared templates that I know of for writing a node pool. I think I have one for my setup, and it's really simple to do. But like if I'm my dev environment, right, I probably can be more acceptable for those smaller nodes. But it's really easy to control that, and it's really easy to, set like your subnets and things like that. And Karpenter will do that automatically for you. I didn't show it in here. I thought it was kind of probably easier to figure it out looking at the documentation, but figuring out through selectors what subnets it should use. But if you have some that don't follow the rules, you can do your own. But I would just restrict those node types based off of the environment and what you need. I think we have 8 minutes left, so.
One of the things that Karpenter does that I'm not used to is I'm used to the ASG, separate ASGs model. And you said, oh, you don't do that. It just makes EC2 nodes directly. Do you just go, the node pools are still like they're in the EKS dashboard instead to sort of see how many nodes, like the thing that is not an ASG anymore is visible in the EKS Amazon, the AWS dashboard?
No, it's not going to be.
Okay.
Because I don't ever use that, to be honest. If I remember correctly, that's just showing you the groups that you have that you've created that are managed, which would have the ASG. And so this isn't using either of that, so it's not going to show up there.
Okay.
So you would, if you needed that information, you would most likely get it from the metrics Karpenter is
Kubernetes,
exporting. Yeah. Or you could, search by the tags on the nodes.
Okay.
Especially if you're doing a setup where you have a couple clusters in the same account, you would end up having to do it that or use the metrics to do it.
The only other thing, we looked at Karpenter and didn't move to it yet, but I still would like to. Our main thing is that we have a set of pods across few availability zones like you should, and we're using EBS for our EBS storage with CSI, and often when we have unschedulable pods that we're using a PVC, cluster autoscaler will make a new node in the wrong ASG because it has no idea about what the thing is, and my understanding is Karpenter actually takes that into account when it's looking at the pod scheduling.
Yeah, Karpenter will look at that on the pod and make sure that it goes in the right AZ. It used to not be as good at that, but since they've hit version 1, I haven't had any issues with it. Now, you said CSI, so I'm assuming you meant pod level storage, right? For EBS? Yeah. That's honestly that's probably another big thing I didn't even think about with this, right? Is that you're going to get the node in the right AZ for that, because already reattaching an EBS to a node is already kind of slow.
Yeah.
And so you wouldn't want that. Unfortunately, even the over provisioning you were talking about is not going to help that. That's just going to be an extended amount of time, which is a bummer. Oh, and I forgot, I didn't mention it, but everyone should do this. Make sure you set resource requests on your pods. Like, Karpenter needs to know what you're using for it to pick the right node. So it's not going to do a very good job of doing that. There's nothing to keep you from running Karpenter side by side with Cluster Autoscaler. And you can slowly move your workloads over to Karpenter. I think that when I first set up Karpenter, I had the whole thing done and moved over in a couple of hours. It's really simple. And figure if a schmuck like me can do it, I think you guys will be all right. But yeah, you can totally transition to it over time. You know, pick a lower environment, you know, dev or stage or your CI system or whatever you want to do to try it out and, you know, see the savings. I don't know what you guys are using for savings. There's plenty of tools out there if you want to use OpenCost or something, and so you can kind of like try to track your savings. But if you follow the rules of being more generic, like I said, I'm pretty sure you guys will get pretty significant savings out of it. Just don't ask for a very, very specific instance type unless it's for a savings plan.
Okay.
Yes.
Thank you so much. So since we started talking about the savings, right, Karpenter is claiming to be very cost effective comparing to Cluster Autoscaler. Do you have any numbers, like, for example, you've been able to cut down like 50% of your bill or 30% of your bill? I would be happy to hear about that a little.
So it's really hard to say, you know. If you're able to do a savings plan, if you're super specific, I don't believe the number they say it's like 90% or something silly like that. I think I saw 58% for my stuff for a savings plan. Mm-hmm. But to use a savings plan is, you know, it's an hourly commitment. So, you know, middle of the night, right? Like that's like your lowest, you know, the least amount of nodes you have. That's probably all you're going to want to do for a savings plan. You just want it for like to cover the bare minimum. Because if you go over that, you're paying for it whether you use it or not. But if you're super generic on the node pools, you should be able to always get spot. And I think when I first switched over for GPU, I was getting like 70-some%. And like I said, there was 67% of mine were on GPU. But that was with me, you know, getting 500 nodes on a Sunday and then, you know, running them on spot and then getting rid of them. And now it's, you know, don't get spot for GPU 6 in US West 2. It's going to be a bad time for you. You're not going to get a node, and it's going to be expensive. I'm sorry for everybody that needed that.
Thank you.
Well, thank you very much for a super informative talk.